LeChatelier's principle states that when stress is applied to a system at equilibrium, the reaction shifts to relieve the stress and regain equilibrium. Chemically relevant stress includes a change of temperature, which is related to the addition or removal of heat, and increasing or decreasing the concentration of products and or reactants. For example, let's look at a chemical system at equilibrium. The reaction of 1 mole of gaseous carbon monoxide, capital C, capital O, parentheses G, end of parentheses, reacting with 2 moles of gaseous hydrogen, capital H subscript 2, parentheses G, end of parentheses, which is in equilibrium with 1 mole of methanol, capital C, capital H subscript 3, capital O, capital H, parentheses G, end of parentheses. Methanol is not a name you should know, by the way. If we add more carbon monoxide, which is a reactant, to this system at equilibrium, the reaction will shift to the right to decrease the concentration of carbon monoxide. The concentration of hydrogen will also decrease, and the concentration of methanol will increase. The concentrations will establish themselves, so the ratio of product to reactants in this equation remains constant. On the other hand, if we added more methanol, which is a product to the system, the reaction would shift to the left. The concentration of carbon monoxide and hydrogen would increase as the system reestablishes equilibrium with new concentrations. The concentrations of chemicals can change, but the ratio of products to reactants at equilibrium will always be the same number, the equilibrium constant. We aren't given a value of K here, but there is a numerical value that scientists have experimentally determined for this reaction at specific temperatures. Another stress is the removal of a product from a system at equilibrium. If we remove a product, the reaction will shift to the right to form more product. This is a way to force a chemical reaction to produce more product, and it is an approach that is utilized by many biochemical reactions.